Hello everyone, it's Miss Thomas, and today we are going to look at bisectors. So to bisect means to cut into two equal pieces, so to cut in half. So an angle bisector is going to cut an angle in half. So it can be a ray, a line, or a segment that divides an angle into two congruent angles. So we have an example here. It says, in the given figure, ray OB bisects angle AOC. The measure of AOC, so the measure of the whole angle, is 7x plus 2. And that of COB, so this one down here, is 5x minus 8. We want to find the measure of AOB. And so in this question, when they say find the measure of AOB, we're not just looking for another 5x plus 8, because that's what it will equal. We want to find the actual numerical value. So let's do some marking first. Since we know that OB is the angle bisector, we want to go ahead and mark these two angles congruent. So I know that this is 5x minus 8 degrees, and I also know that this has to be 5x minus 8 degrees, since OB is the bisector, and that makes the two smaller angles congruent. And then I know that this entire angle from here to here, the whole thing is going to be 7x plus 2 degrees. So now we're going to just use our angle addition postulate, and we are going to go ahead and set up an equation. So 5x minus 8 plus 5x minus 8, I'm just going to go ahead and make it 2 times 5x minus 8 because there's two angles that equal the same thing, equal the whole angle, which is the 7x plus 2. So going ahead to solve this, I'm going to distribute the 2 in and get 10x minus 16 equals 7x plus 2. I'm going to subtract my 7x over. So I'll get 3x minus 16 equals 2. Adding the 16 over to cancel it out, to isolate that variable. And I get 3x equals 18. So dividing both sides by the 3, I know my x is going to equal 6. So that's just sort of step 1. We want to figure out what's the actual measure of angle AOB though. So the measure of angle AOB is going to take that expression that represents it, 5x minus 8, and now I'm just going to plug in that x value of 6. So it's going to be 30 minus 8, measure of angle AOB equals 22 degrees. So a segment bisector is going to work just like an sector. It's a ray, line, segment, or plane that divides a segment into two congruent parts. So we have this example, and the figure shown below, A, M, and B are collinear. So A, M, and B are collinear. Line segments X, Y, and AB bisect each other. So whenever you're given information like that, go ahead and mark it on the diagram. So if X, Y, and AB bisect each other, then that means that AM is going to be congruent to AB, and it also means YM, I don't mean AB, I mean MB, Sorry about that. Okay, and ym is going to be congruent to mx. Okay. We know that am, which I'm going to mark with black, am is 3x plus 6. We know that mb is 4x minus 1. And we know that mx is equal to 2x plus 4. So we want to think about what information we have where we can start solving for the variable. We know that the 2x plus 4 and this segment right here are going to be equal, but we don't know how big this segment is, and we don't know how big xy is, so we can't really do anything with that xy yet. On the other hand, we do know that the 3x plus 6 should equal the 4x minus 1 because am and mb are congruent. So we're going to go ahead and use that to set up an equation. And I'm going to subtract that 3x over to the other side of the equation. So I can cancel it out. So then I'll have x minus 1 on the right. Adding the 1 over, I'm going to get that x equals 7. So knowing that x equals 7, I'm going to go ahead and plug that in. If x equals 7 for am and mb, then that should also be true for mx. So to find out the length of mx, I'm going to do 2, take my 7, and add it in. So it's going to be 14 plus 4, so it's going to be 18. So I know that ym is going to be equal to 18. Mx is going to be equal to 18. So then xy, which is the entire length, is just going to double that because they're both equal. So it's going to be 36. The midpoint is what it sounds like. The midpoint is the coordinate of the point halfway between two endpoints. It's the location of the intersection of the segment and its bisector. So we want to find the midpoint of the line segment. So from a graph, we can kind of just intuitively know where the midpoint is. We want to think about the fact that, you know, we're trying to find halfway between these two endpoints. And we can think a little bit about, okay, well, what's the change in x over this line segment? Okay, and you can just easily count that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that the midpoint is going to happen at 4.5 because 9 divided by 2 is 4.5. So it's going to be 4.5 units away from either end. So if I go 4, 1, 2, 3, 4 and a half, I know my x value is going to have to be a 0.5, because that's 4.5 units away from the end. And that should also be 4.5 units away from this end, just to double check. 1, 2, 3, 4, and then you've got that half. So we know we're in the right place for the x. So it's going to be this right here, which looks like it's at y equals 1, because that's where x equals 0.5, but we just want to double check. So we can just go ahead and figure out the vertical distance. So we have 1, 2, 3, 4 units. So that means that we need to move 1, 2 units to get to the halfway point of that vertical change. And that is definitely here at y equals 1. But we want to write our midpoint as a coordinate, and it is the coordinate 0.5, 1. So sometimes we want to use the midpoint formula. And the reason for that is we're given the coordinates, we don't want to take the time to graph it, or maybe the coordinates are really far apart and you don't want to sit there and try to calculate that by hand. So we do have a formula, and it is really just following in what we just did. So the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. And what this really just is, the midpoint formula, it's an average of the endpoints. Okay? Which makes a lot of sense because we're trying to find halfway, and since there's only 2 endpoints, then that's going to be the average. So we're given the points 1, -2, and -3, 5. We want to find the midpoint of the line segment joining them. And so it doesn't actually really matter which one's x1 and which one's y1, just that you have them matched up the same. So x2, y2. So to find the x-coordinate, we're going to go 1 plus -3 over 2. And then to find the y-coordinate, we're going to go -2 plus 5 over 2. And we just want to go ahead and simplify that. So 1 plus -3 is going to be a -2 over 2. -2 plus 5 is going to be a 3 over 2. So this simplifies to a -1, 3/2. And that is the midpoint. So sometimes you're given an endpoint and the midpoint, and you want to find the other endpoint. So in this case, you might want to break your midpoint formula down a little bit. So the x of the midpoint is your x1 plus your x2 over 2. The y of the midpoint is your y1 plus y2 over 2. So it's the same formula as this, we're just making it more into an equation now. So my x's are -1 and -9. Since this is the midpoint, this is my xm. So -9 is equal to -1 plus x2, because I don't know my other endpoint, over 2. So now to start solving this, I'm going to multiply both sides by the 2. So -18 is equal to -1 plus x2. So x2 is going to be a -17. And then we want to look at the y's. So we have a 9 and a -10. Again, because this is the -10 is from the midpoint, that means it's my ym. The little subscripts just name things and help you keep them straight when you have more than one variable. So my -10 It's going to equal my y1, which is a 9, plus my y2, which I don't know, I'm solving for that, over 2. So then multiply both sides by the 2, you get negative 20 equals 9 plus y2. So then y2, when I subtract that 9 over, it's going to be a negative 29. So my midpoint coordinate, nope, sorry, my other endpoint is going to be a negative 17 and a negative 29. And you want to write all of your endpoints and midpoints as coordinates. So your U-try is to find the midpoint for line segment AB if A is located at negative 3, negative 10, and B is located at negative 16, 1. So try this out, and I'll see you in class tomorrow.